this satellite image can be sourced from various sources. It could be satellite image from platform like Google Earth. It could be you can query some organizations that handle satellite imagery. That is, you demand for image, you can get. You can actually fly drones. You fly drones at a particular elevation or altitude, you get satellite images. You can also be on a higher spot, maybe on a mountain or a skyscraper structure, and you can also get a screenshot of the urban scape of any city or region that of your choice. Now, after understanding the raster, this is now a raster. Know that any image is a raster image. Okay, any image is a raster data. As far as an image is a raster data, you can see it here. This is actually what we call a raster data. So now, by the time we now say, okay, we now take this into our ArcGIS, we now say, okay, we want to trace this green field. When you use what we call shapefiles, I will come to that. I'm just introducing it to us. We use a shapefile or a layer to trace this green land or green space or open space or spotting space, whatever you call it. Now, when we trace it, we use polygon to trace this. After tracing it, the outcome of that tracing is what is known as the vector data, just as how I've explained earlier on. Now, let's see the stimulation of what actually the system or computer or the camera or whatsoever understand as a raster data model. Now, this very stadium at my right, it's the one here in the black and white format. Now you can see that the resolution or the quality of this image is dropping drastically. From here it's now dropped, from here it dropped further, from here it dropped further, it dropped, and from what you can see down here, you can see it's a pattern of like a square, like it's tiny as squares, and you can see the combination of you have gray, we have white, you have black. Now that is what a raster data model is. It doesn't see the image as we see here, it rather senses it as this. This is what we call color bands. We call them bands. We use color bands to effect the coloration, and then it brings out something like this. Now this image, now I now try to get a concept of this, a matrix actually. Now it might not really explain what is here, but I'm going to try to use it. Now you can see there are spots where we have white colors here. The white colors can be, you can use them as B, but let me try and explain. This squared like pattern you are seeing here is actually the pixelated format of this image, and in the pixelated format you can have things like AAAA. You can see the A has been mapped in different sections. It simply means that this region is for agriculture. You can now see RRR. Anywhere you see R, it means it's a river. So it means there's a agricultural land and there's a river bounding it. And then we have a forest. We have forest where you see FFF is forest. And then we have H. Wherever you see H is a highway. So with this is a raster data model in a matrix form. With this, you can be able to understand that in this image we have agricultural land, forest land, river, and a highway. There's actually a highway in between this structure or this image. So it's similarly, it's the same thing that is applicable here. By the time we go deeper, we can now explore the attributes. These are actually attributes. The attribute of this city image of this with this stadium is actually pixelated under this. So that's what raster image is. This image is a raster, and it forms this. The quality drops and it becomes a matrix full of X and Y data, and this X and Y are called cells. Note that I'm not using coordinates, I'm rather using X and Y cells. These are just X and Y cells. We put them in pattern of X and Y. Okay, all right, so let's go ahead. Now I now say, okay, we have from this picture, from this image, you see this is a raster data model type. And I now say that this is more examples on types of raster data. Now this is an image of the world trying to show us the vegetation cover. This actually, there's what we call NDVI, normalized differential vegetation index. This image is a normalized vegetation index, NDVI, for the whole world. Is actually a raster image. Now this is a drone image. This image was captured from, this is a harbor. This is a ship loaded with containers close to a harbor of a city. This is also a raster data. This is satellite image of the permanent site University of Jos that I got, is also a raster image, and this is also a satellite image of a region showing a landslide. You can see the color format is different. It's also a raster data model. So what are the clear distinctions between a raster and vector? Raster are simply the data or the image we get either from satellite images, whether it is shared, whether it's from drone, whether you snap it yourself, and you bring it into GIS. Is a raster, GIS software rather, is a raster data model. While when you commence tracing of the features, whether it is natural or anthropogenic, that is natural as rivers, water bodies, whatsoever you call it, vegetation cover, or you are coming to anthropogenic, things constructed by man, building roads, the act of tracing, we use vector model to do those tracing. So that is the major difference. And at the end of the day, you produce a plan, or rather let me say we produce a map of that. It will now be like a base map of that study area. So tracing, the tools we use to trace polygons, whether I use polygons, line or point, these are vector data. We use them to trace the features on a raster data, and the raster data is now your image. I hope that has been able to clear up some confusion. All right, so let's go ahead. Now there's also another confusion or complexity or ambiguity in understanding GIS software options and landscape. Now this simply refers to the software programs and websites in which geospatial data and information can be queried, extracted, sourced and manipulated. Okay, now GIS as geographical information system or data can be in various forms. We have platforms that you can source for GIS data online. We have the desktop formats such as the QGIS, the ArcMap, the ArcGIS, and we also have server versions. Now let's go ahead and look at GIS software landscape. We have the commercial GIS. We have companies or institutions like ESRI, that's Environmental Research System Information. They operate GIS. They have GIS Enterprise. They also have the space, the cloud space as GIS Online. We have the IDRIS, we have the UGS GIS, we have the Global Land Tree, we have the Google Earth Engine. All these places are commercial platform which GIS software could be sourced. The issue of QGIS or ArcGIS is just an option of softwares. The most important thing is to know that GIS data can be sourced from a lot of sources. The QGIS or the ArcGIS is just a software platform which you can utilize to analyze those data, to manipulate those data, to effect changes and produce maps or whatsoever you want to design from it. Now we have free with premium options like the ArcGIS Enterprise and Katos. These are actually spaces you can also get GIS data or geospatial data, but they are being paid, they are not free. Then we have what we call the open sources. The open sources like the QGIS, we have the GRASS, we have the Leaf Map, we have the Mapbox, we have the ArcGIS or the ArcMap, we have the GIS Pro, and a lot of them. They are open sources because they are free. In another case, you can also call it they are desktop free. You can actually get them on net, download them and begin using it. Then we also have other platforms like the Google Earth, the PostGIS, the Map Info. We have a whole lot of platforms, whether it's online, whether they are online or a desktop or server version, whether it's desktop or server, just as I said. So that is one of the most important things. I always make emphasis on this. We need, or if you are venturing into GIS, you need to understand this concept, very, very key. GIS, when we say GIS, we are not just talking about ArcGIS or ArcMap. No, we are talking about geographical information system. Any such information you can get from any source that is talking about features, whether man-made or artificial, whether it's man-made or natural, that is occurring on the earth's surface, is actually what we call GIS. But it has geographical system, it has coordinates. So we just collect information, whether it's through satellite, whether we fly drones, whether we take snapshots, whether we scan the images. all of those things, those methods are under GIS. Now the QGIS, the ArcGIS is just a platform. It's just a software platform that you can use to be able to